So we're at the bottom of page number 17. So if you're not on page 17 already, I need you to pause and open your guided notebook to page number 17. So we want to think about this question. When you divide a non-zero whole number by a proper fraction, how does the quotient compare to the whole number? Explain your reasoning. When dividing a non-zero whole number by a proper fraction, the quotient is blank, then the whole number, dividend. The quotient is greater than the dividend because each equal segment is less than 1. Therefore, the number of equal segments is always greater than the number of whole number segments. For example, so that was a bunch of words and I don't know what that's talking about. So I like to do an example. So I started with a non-zero whole number, and that non-zero whole number that I decided to use is 8. So I made my own expression. So I have an 8. And then the proper fraction is going to be 2/3. And remember, a proper fraction is when the numerator is less than the denominator. So I'm going to figure out what the quotient is and compare it. That way I can understand if it's less than or greater than. Write an example. So we have 8 needs to be divided evenly into groups of 2/3. So you have to start with what number? The dividend, the number to be divided. So if you look here, I've started with 8 whole rectangles. Those rectangles are separate. So I have 1, 2, 3, 4, 5, 6, 7, 8 whole rectangles. And what do I need to do with those rectangles? I need to divide it evenly into groups of 2/3. So in order to make groups of 2/3, I need to first show thirds. So that means I need each whole to be broken up into thirds, which means I need 2 lines. 1, 2 lines. So I need 2 lines here. So this is going to be 1/3, this is 2/3, and this is 3/3. And 3/3 is my whole rectangle. You can't really see that. So 3/3 is my whole rectangle. So I'm going to go ahead and I want you to go ahead and divide your rectangle into thirds. Now that my rectangles, my 8 whole rectangles are divided evenly into thirds, I can make groups of 2/3. So here's one way to show it here. I'm going to show it another way. So this is 1/3, 2/3. So that's going to be a group. 1/3, 2/3. This is a group. 1/3, 2/3. I have to make groups of 2/3 until I have nothing left of my 8s. So I can do 1/3, 2/3. That's another group. 1/3, 2/3. 1/3, 2/3. 1/3, 2/3. How many groups of 2/3 are in 8? 1/3, 2/3. 1/3, 2/3. How many groups of 2/3 are in 8? The number of groups that we circle is going to be our answer. You have to make sure you're out of 1/3 before you start counting your groups. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 groups of 2/3 in 8. So I can easily compare the non-zero whole number, non-zero whole number, write this down. Non-zero whole number is 8 compared to the quotient. So I'm going to compare my non-zero whole number and my quotient. And my quotient I see is 12. And I'm just going to check over here. So 8 divided by 2/3. So dividing by 2/3 is the same as multiplying by 3/2. And I want to make my 8 a fraction, because when I multiply fractions, I can only multiply the numerator times the numerator and the denominator times the denominator. So I like to make my whole numbers fractions so I don't end up with the wrong answer. So I have 8 times 3 for the numerator, which is 24. And then I have 1 times 2 for the denominator, which is 2. 24 divided by 2 equals 12. So I know that the quotient is really 12 using math and using the model. So I can compare 12, which is my quotient, is going to be greater than my non-zero whole number 8. And the reason because if I look here at the modeling, this is one whole group. So every time I make a group of 2/3, I'm not taking the whole group away. I still have a section left over. This section right here is still left over, and that's 1/3. So every time I take away a whole group of 2/3, I'm going to have 1/3 left, which means the groups of 2/3 will be higher than the 8 that I originally started with. So let's model this on a number line. So we have to start with our dividend. So that means I need a number line that goes from 0 to 8. And then I'm going to put my other numbers. So this is going to be 4. And this is going to be 2. And then halfway between 4 and 8 is 6. Halfway between 0 and 2 is 1. Halfway between 2 and 4 is 3. Halfway between 4 and 6 is 5. Halfway between 6 and 8 is 7. In order to show groups of 2/3, I need to first break my number line into thirds, which means I need 2 lines. 1, 2 lines. So now I have 3 equal sections between my whole, but I have to do that for all of my wholes. Between all of my whole numbers, I need to add 2 lines. So go ahead and do that. And then I'm ready to start modeling once I have my 2 lines. So where do I start modeling at? Well, the division expression says 8 divided evenly into groups of 2/3. So I'm going to start at my dividend, which is 8. And then I'm going to make groups of 2/3. So this is going to be 1/3, 2/3. That's one group. 2 1/3 make 2/3. 1/3, 2/3. That's another group. 1/3, 2/3. 2 sections of 1/3 is going to make one of my groups. Now you have to repeat subtract until you get back to 0, because that means that you're going to use all of the 8 wholes up and get the proper number of groups of 2/3 and 8. So we go 1/3, 2/3, 1/3, 2/3, 1/3, 2/3, 1/3, 2/3, 1/3, 2/3, 1/3, 2/3, 1/3, 2/3. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are a total of 12 groups of 2/3 and 8. So the question that we answered with this model is, how many groups of 2/3 are in 8? That's the question that we answered, and the answer is there are 12 groups of 2/3 in 8.